In the last video, we had discussed the different measures of central tendency like mean, median, mode, geometric mean, harmonic mean, etc. So in this video, we will move on to the measures of dispersion. Dispersion is nothing but variability or spread. So we are actually trying to study the extent to which the distribution is spread. So now we move on to the measures of dispersion one by one. Range, mean deviation, quartile deviation and standard deviation. So range is nothing but the largest value in a set minus the smallest value. So in a data set you have a series of observations. In that you subtract the largest value with the smallest value and then you get the range. Mean deviation, quartile deviation and standard deviation. Standard deviation, as we know, is the square of the root of the variance. So variance is nothing but standard deviation the whole square. And mean deviation and quartile deviation, the problems related to that we will discuss in the coming sections. Quartile deviation also has another name, semi-interquartile range. So quartile deviation is also known as semi-interquartile range. We have range, which is the largest value minus the smallest value, and we have standard deviation, which is variance equal to standard deviation the whole square. So next we move on to another concept, coefficient of variation, otherwise denoted as CV. So the standard formula of CV is standard deviation by arithmetic mean into 100. So coefficient of variation or CV is given as standard deviation by arithmetic mean into 100. So since standard deviation and arithmetic mean has the same unit, the coefficient of variation has no unit. So when you solve for the coefficient of variation, standard deviation by arithmetic mean, we get a number. It has no unit. And what is the coefficient of variation used for? It is used to compare two data sets. So coefficient of variation is basically used to compare the variability among two data sets. So say suppose if you have two data sets, you calculate the coefficient of variation for these two. So you have CV1 and CV2. Suppose if CV1 is less than CV2, what does it imply? So the data set which has the lesser coefficient of variance, in this case 1, that data set will be more consistent. So the lesser the coefficient of variance, more the consistency of the data. So that is what is said here. So as coefficient of variance decreases, like in this case coefficient of variance of data set 1, consistency or reliability of the data set increases, that is the variability decreases. So that is the basic idea. So what if all the observations in a data set are the same? So basically there is no variance. So standard deviation is basically the square root of variance. So since variance is 0, standard deviation will definitely be 0. In that case, coefficient of variance will be 0 by arithmetic mean into 100, again will be 0. So when all the observations are same, there is no variability in the data set. So in that case variance is 0, standard deviation is nothing but the square of variance, so that will also be 0. So putting that in the coefficient of variance formula, we have standard deviation by arithmetic mean into 100. So 0 by arithmetic mean into 100 we will get 0. So the coefficient of variance will be equal to 0 provided the data set has all the same observations. And additionally, these measures of dispersion are also called averages of second order. So measures of dispersion are also known as averages of second order. So coefficient of variation CV, standard deviation by arithmetic mean into 100, it is used to compare two data sets, and this is how it works. And measures of dispersion are also called averages of second order. So in this case, so this is a problem related to the coefficient of variance. CV is equal to 75, variance equal to 225, what will be the mean? So now we know that coefficient of variance is equal to standard deviation by arithmetic mean into 100. So in this case we know that CV is equal to 75. Standard deviation we don't know, but standard deviation is nothing but the root of variance. So standard deviation is equal to root of variance, root of 225 will be 15. So from the value of variance we get to know what the value of standard deviation is. So standard deviation is 15 divided by mean is what that we have to find, arithmetic mean into 100. So basically 75 arithmetic mean is equal to 1500, arithmetic mean is equal to 1500 divided by 75, which will be 20. So we have coefficient of variance equal to 75, variance equal to 225. What is the value of mean? So this is the standard formula. CV is equal to SD by arithmetic mean into 100. Substituting the values, we have CV is 75. SD is not directly available in the question, but we have variance. So we take the root of variance. Root of 225 is 15, which is the standard deviation. You substitute it. So 75 is equal to 15 by AM into 100. So 75 AM equal to 1500. So AM is equal to 1500 divided by 75, we get the value of 20. So these are few properties related to measures of dispersion. You just have to know what these properties are and not in detail. So the first property is sum of the squares of deviations of observations is minimum when taken from the arithmetic mean. So when we take each of the observation x minus from the arithmetic mean and you take the square of it, so sum of the square of the deviation of observations is minimum when taken from the arithmetic mean. So this value will be minimum. So sum of the squares sigma. So sum of the squares of the deviations of observations is minimum when taken from the arithmetic mean. So this is the mathematical notation for this statement. Secondly, mean absolute deviation is minimum when taken from sigma xi minus a by n is minimum when a equal to median. So when the mean absolute deviation is minimum when taken from sigma xi minus a by n, where a is equal to median. So this is another property of the measures of dispersion. Additionally, we have few formulas. So range is equal to 6 times standard deviation. Quartile deviation is equal to 2 by 3 standard deviation, and quartile deviation is also 5 by 6 mean deviation. So these problems related to find out the range given the standard deviation, find the quartile deviation given the standard deviation, or find the mean deviation given the quartile deviation. In those cases, these formulas are used. So range is equal to 6 times standard deviation, quartile deviation is equal to 2 by 3 standard deviation, and quartile deviation is also written in terms of mean deviation, which is 5 by 6 mean deviation. Now MD from median is equal to 4 by 5 standard deviation. So this is the relation between mean deviation and standard deviation if mean deviation is taken from the median, and the ratio relation between quartile deviation, mean deviation and standard deviation is equal to 10:12:15. So quartile deviation is to mean deviation is to standard deviation is equal to 10:12:15. Additional property is mean plus or minus 1, 2, 3 times includes 68.26%, 95.4% and 99.7% of the observations. So what does this statement mean? Mean plus or minus 1, 2, 3 times includes 68.26%, 95.4% and 99.7% of observations. So what this actually means is that mean plus or minus 1, 2, 3 times. So we take each case. Say suppose mean plus 1 into standard deviation and mean minus 1 into standard deviation. So the interval between these two, the range between mean plus 1 into standard deviation and mean minus 1 into standard deviation, that particular interval will have 68.26% of the data. That is what the implication of the statement is. So mean plus 1 into standard deviation and mean minus 1 into standard deviation, that range will hold 68.26% of the data. Similarly, if we take mean plus 2 into standard deviation and mean minus 2 into standard deviation, that particular range will have 95.4% of the data. And if you take mean plus 3 into standard deviation and mean minus 3 into standard deviation, that interval will have 99.7% of the data. That is what the statement implies. So now that we have seen the properties of the measures of dispersion, let's move on to few problems. So if MD equal to 8 for a moderate distribution, what is the value of variance? So the properties that we have seen is for a moderate distribution. So what do we know about the relationship between mean deviation and variance? We do not have a direct relation, but still we have mean deviation is equal to 4 by 5 standard deviation. And we know that variance is standard deviation square. So mean deviation is equal to 4 by 5 standard deviation. We know mean deviation is equal to 8, 4 by 5 standard deviation. So standard deviation is equal to, taking 5 to the other side, 8 into 5, 40, divided by 4, we have 10. So in this question there is an option A, 10, but if we mark this, it will be the answer for only standard deviation, and the question is for variance. So we need to square this. So variance equal to SD square. 10 square is equal to 100. So it's not option A, it's option B. So in this question we have given the mean deviation is equal to 8, and what is the value of variance? So the relation between mean deviation and variance is given by standard deviation. So mean deviation is equal to 4 by 5 standard deviation. So substituting the value of mean deviation as 8, we get 8 is equal to 4 by 5 standard deviation. So standard deviation is equal to 8 into 5 by 4. So 8 into 5 is 40, divided by 4 we have 10. So even though there is option 10 in the given codes, it is not the answer because they have asked for the variance. So we have to take the square of the standard deviation, which is 10 square, which is 100. So option B is the answer. So next question, QD is equal to 4, quartile deviation is equal to 4. What is the value of variance? So again the relationship between QD and variance directly does not exist. So we take the relation in terms of standard deviation. So we know that quartile deviation is equal to 2 by 3 standard deviation. So we substitute 4 is equal to 2 by 3 standard deviation. So in that case standard deviation will be equal to 4 into 3 by 2. So this will be 6. Again there is an option B which states 6, but they have asked for variance in the question. So we need to take the square of the standard deviation. So SD square, variance is nothing but standard deviation square. So 6 square is equal to 36. So in this case quartile deviation is given, we have to find the variance. Quartile deviation is equal to 2 by 3 standard deviation. So rearranging it, we get standard deviation is equal to 6, but since the question is asked for variance, we need to take the square of standard deviation. 6 square is equal to 36. So option A is the answer.